How's everybody doing out there? Well, today we're starting our unit on Chapter 8, which is hypothesis testing with one sample. So the good thing is this is very similar to what we had worked on in Chapter 7 when we were doing our confidence intervals. So this was the beginning of our inferential statistics section. And so this is going to push that we learned in Chapter 7 a little bit further. And so instead of just using our confidence intervals, we're going to be able to use probabilities to determine whether our claims are true or false in these cases. So what we're going to do is we're going to do a little background information to make sure we know how to set up our hypothesis test. And then eventually we'll get to where we're actually doing some hypothesis tests and things like that. So just to kind of remind you a little bit about what we did in Chapter 7. So I'm using a little example here about how we had a machine that made cereal boxes that put 20 ounces of cereal in each box. And so I went ahead and kind of set up our confidence interval. And so a question that they may have asked is, does it seem like that the machine is putting at least 20 ounces of cereal in each box? And so if we go to our confidence interval, we can see that it actually appears that it's putting more than 20 ounces in. And so if that were our claim that it was more than 20 ounces, then this confidence interval definitely supports that claim and everything would seem perfectly fine with that. So what we're going to want to do is push that a little bit further and use probabilities to show that this is actually in fact true in that case. All right, so let's take a look at a couple different hypothesis tests that we're going to be working on in this chapter and the next chapter. So the first type that we're going to be working with is testing a claim about what the population mean is given the population standard deviation. And so if you remember from Chapter 7, that's exactly what we were doing with confidence intervals in 7.1. It's the exact same setup. So the second type we're going to work on is test a claim about the population mean without knowing the population standard deviation. So in this case, this means using the sample standard deviation. And so again, if you remember, this is exactly the types of problems we dealt with in 7.2. And then the third bullet, test a claim about what the population proportion is. And so that was chapter 7.3. So these first three hypothesis tests that we're going to be working on are what we're going to be doing in this chapter. So these are all going to come from chapter 8. These are all what are called one variable hypothesis tests. So starting with the next two, so notice we're talking about the testing a claim about the difference between the means of two populations and the difference between the proportions in two populations. So these are both going to be two variable hypothesis tests, and these are going to live in chapter 9. So we'll get to those after we finish up chapter 8. All right, so first thing let's talk about is the most important part of our hypothesis test, and this is actually setting it up and being able to write down what our hypothesis looks like. So our hypotheses are broken up into two categories. So we have what's called our null hypothesis and our alternate hypothesis. And so these are two contradictory hypotheses, which means that only one can ever occur at any given time. And so when we set these problems up, what we're going to do is we're going to set them up in such a way that whatever we're trying to prove is true, whatever our claim is going to be written as our alternate hypothesis. And then the null hypothesis is just the opposite statement of that. So when I talk about opposite statements or contradictory statements, if we look at some examples of how these will be set up, so in the first case, if our H naught is mu is equal to some value, then the opposite statement of that is that mu is not equal to some value. So those two statements are always going to go together, equals and not equals. Similarly, for the next one, we've got mu is less than or equal to, so the opposite inequality for that would be mu is greater than that value. And then finally, the last case is if mu is greater than or equal to, then our alternate has to be mu is less than whatever that value happens to be. So that's going to be the first thing we do. And then the last thing that we actually do is our conclusion, which is going to fall into one of these two categories. So either we're going to reject H naught, which means that we're saying that H naught is false, which implies that H1 is true, or for us, that means our claim is true. So this is kind of the ideal situation. So if it doesn't happen, it's fine, but that's kind of what we're hoping happens, because if our H naught is false, then that tells us for certain that our H1 is true, and everything's great. All right, so the other possibility is instead of rejecting H naught, so notice we don't use the word reject H1 or anything like that. So what we use is the word fail to reject H naught. So that doesn't necessarily mean that H1 is false, which implies H naught is true. So it's not that. So that's definitely not true. So, because unfortunately there's no test that we can do that's ever going to show that H naught is true. So the best thing that can happen if we say that we fail to reject H naught is this just means that there isn't sufficient evidence to prove our claim about H1. So either, maybe something was wrong with our sample, maybe something was wrong with our claim, but either way, we never can prove that H naught is true. So we can prove H1 is true, but we can't necessarily prove that H naught is true. All right, so let's take a look at a couple examples here about trying to accept or reject a claim that's given to us. And again, we're going to do these without using any math or anything. We're just going to think about them and see if they seem reasonable. So for practice 1, a coin is fair and heads turns up 27 out of 30 tosses. So does this seem like a reasonable claim? Should we accept it, or does this seem like not a good claim and we should reject it? So since flipping coins we know is about a 50-50 chance of flipping heads or flipping tails, this would seem pretty unlikely that you would flip a coin 30 times and get 27 heads in the process. So this would be a good, reject the claim. Because in reality, we should expect this number to be about 15, 13, 14, 16, somewhere around there. Any of those numbers would have been something that we could have accepted the claim on. But having 27 out of 30, that's almost 90% or around 90%. That's going to be pretty unlikely if our coin is fair, like we're given in this case. All right, so let's look at practice 2. So women who eat blue M&M candies have a better chance of having a baby boy. 50 women gave birth to 27 boys and 23 girls. So the claim is that women who eat blue M&Ms are going to have a better chance of having boys. So notice in this case there are more boys than girls, but not enough that it would be significantly different, because we know the probability of having a boy or a girl is 50-50. So again, these are pretty close to 50-50 each one. So again, for this reason, I would say we can reject the claim. All right, so let's take a look at the next couple practice problems here. And so for these, we're trying to determine what the claim would be, and then try to think about common sense whether this claim seems legitimate or we should accept it or reject this claim. So practice 3, as the owner of the Travel Safe Auto Insurance Company, you observe that one customer, Lisa Kerr, has filed a claim for a different stolen car in each of the past 5 years. So if we use this one particular person as our sample for the claim, then we'd probably claim that every customer has a car stolen each year. And so I would say that's pretty unlikely that that's actually legitimately true. So I would say there's probably something going on with Lisa. Either she just has the worst luck of any person in the world, or she's behind all these car thefts. Who knows? But either way, this seems like not a valid claim. So I would say let's reject this claim. All right, let's look at practice 4 then. So the rate of Lyme disease cases in Frederick County is 2%. When 1,000 people from that county are given a placebo, it's found that 22 of them contract Lyme disease. When 1,000 people from the county are given a new experimental vaccine, it's found that 18 of them contract Lyme disease. So our claim would probably be something along the lines of the vaccine reduces your chance of getting Lyme's disease. And so if we look at the actual numbers in this case, so like we saw the placebo was about 22 out of 1,000, which is about 2.2% in this case. And so if we look at the vaccine people, so we had, 18 out of 1,000, which is going to be 1.8%. And so technically if we rounded these, notice they would all end up rounding to right around that 2%. And so even though we did see a little bit of reduction between the 22 and the 18, that could have just been sheer luck or anything. Like there isn't really enough significant evidence to prove that the vaccine caused that little teeny weeny bit of difference. So I would say we could reject this claim as well. All right, so I'm going to stop here real quick so you can take a little bit of a break, and then we're going to come back and look at some examples of how to set up the null and alternate hypothesis, because that's going to be a really important part of when we actually get to solving our own hypothesis test. So come back after a little bit of a break, and we'll go through those real quick.